Hi everybody, it's Mrs. Bass. So I thought I'm gonna wear my hat because I am freezing cold. So I'm gonna share my screen. And we went over this in class. So I just really want to take a second to go back. You've practiced with translations. I really want you to practice and have an idea of what we're talking about here, no matter if we're talking about a line, okay, or if our function is an absolute value, okay, or if we have a parabola, okay. It doesn't matter because we can all translate the same. Okay, so it doesn't matter what your beginning function is, you can still translate. So we just wanted to go back over this one more time. I know we did this in class today, okay? So this is your f of x, okay? So this is your function. And this first one, remember, was a horizontal translation. So for example, so I'm gonna make this go through 0, 0 here, okay? So can you see that? How about I put a dot right here in the middle so you can kind of see what I'm talking about. Okay, so I'm going to make this, I'm going to go x minus 3. So this even works with my seniors actually do this, but with more complex functions out there. I'll show you. I'll draw a new one in just a second and I'll show you what they're doing. But what does this mean? So what we do in class in algebra is my students right away go, oh, well, Mrs. Bassett, this is x minus, so it's already a minus, so we have to think opposite when it's inside. So this is 3 to the right, and we usually write 3r, okay? So literally what I would do is I would take, and I'm gonna keep the slope the same. All I'm gonna do is go, oh, how about I not? 1, 2, 3. I keep it looking the same, I just move it, okay? Now, how can I make it go that way? So let's go back. How can I make it go that way? Well, why don't we make it go x plus 3? So remember that it's supposed to be a minus. So if there's a plus, that means 2 minuses make a positive. So this is 3 to the left, which is, oh, this is why Mrs. Bassett doesn't use a mechanical pencil, because it drives me crazy. I like how they write. I just can't stand the lead everywhere. It drives me crazy. Sorry, one of Mrs. Bassett's pet peeves. All right, here we go. Keep the same. So ready? 1, 2, 3. Oops. Same, all I'm doing is moving it. Move it this way, move it that way. Okay, well, let's keep going with the same thing, except now let's move it up and down. Now, up and down is what you see is what you get, okay? So if f of x, and we want to move it up 3, we would put plus 3. So that means to go up 3. 1, 2, 3. Okay, if I want to move it down. Now notice where this is located. Is it inside? No, it's not. Okay, it's on the outside. So this, they usually use the letter K. I always think of like a kite. Okay, a kite can go up and down. And I like to write 3 down. So in this case, here I was at my original, and I go 1, 2, 3. Okay, now let's go back and let's use an absolute value. This is an absolute value function. This is something that we will deal with more in Algebra 2, okay? So the first one was, hey, take this and move it 3 to the right. So I just go 1, 2, 3. See this point? That's kind of my go-to point. See, wasn't that easy? It's not a big deal. Okay, if I want to go to the left, 1, 2, 3. I haven't done anything with the shape of this. Okay, all right, come on over here. If this is to go 3 up, you just go 1, 2, 3, 3 up. If I want to go 3 down, 1, 2, 3. That's it. Okay. If I want to do a parabola has a vertex, same thing. If I start here in the middle, even if you start somewhere else, like say I start over here, this is where I originally was drawn. Okay. I still can go 3 to the right. 1, 2, 3. Okay. If I want to go 3 to the left, I go 1, 2, 3. See, it's not a big deal. So it doesn't have to start right at 0, 0. It doesn't matter where you go. You still can go up 1, 2, 3, or you can go down 1, 2, 3. Notice that I haven't changed the shape of this, have I? Okay, so, and in fact, in these two also, you are not going to change the shape because here we have reflections. Okay, these are reflections. And notice where these, I'm going to highlight with my pen here. Okay, these are reflections. So when we think about a negative on the outside, that's affecting the Y value. So I'm switching all the Y values from positive to negative. So this is a reflection over the X axis, okay? And I'm gonna draw an arrow just to remind myself, okay? So this would be, now let me show you with these because these are really easy to see. Kind of gets a little weird with lines. So instead of an absolute value pointing up, we flip it and it points down. Instead of a parabola pointing up, the parabola now points down. Okay, now this gets kind of, it's weird with a line because with the line, so if you were to take it and flip it, watch this, are you ready? Did you see how I flipped it across? Okay, I flipped it from here to here. Okay, now this one is a reflection over the y-axis, so I'm going here to here. So you're turning the page of a book, okay, turning the page of a book. So in this case, now watch this. Are you ready for this? This is kind of fun. All right, I'm going to flip it over the y. It didn't change, did it? That's because there's symmetry. It doesn't matter. Watch your absolute value. Are you ready? Ah! These are so tricky to pick up. Ha! Again, same thing. It has symmetry. Okay? It has symmetry. Now, here's the interesting part. If I'm switching from here, so if this is at 1, 2, 3, then when you flip it across the x-axis, it would be at 1, 2, -3. How about that? That would be more of, we have friends that have mirror twins. One of them has a dimple on this side and the other one has a dimple on the opposite side. They are mirror images of one another. They're very rare. They are really alike. It's hard to tell them. Even at, I think they're both 5, it is really hard to tell, tell which one is which. I can tell from their personalities now, but it was hard to tell. Okay, so remember here, I'm going to flip it over the y. Okay, so notice here, we're going to change the slope, aren't we? This is a negative slope. And when we flip it over the y, it now became a positive slope. So this is a flip. So what happens is all x values switch signs, but here all y values switch signs. Okay, so for me to show you the next part, I'm going to have to use, only because these are going to change a little bit, okay, I'm going to have to use some yarn, okay, because the translations now actually change the way things look, okay, they actually change the way things look. So if I use a line, actually I can probably use a line still with this, but I just need you to notice where it's going through, okay? So when you have a multiplier of A, this is going to be a vertical stretch or shrink, okay? But we're talking vertical. Now, if we're talking vertical like a yo-yo, that's affecting the Y values. So stretch versus shrink would be like taking a picture and stretching it or shrinking it. So when you take a picture in, like you're putting a picture in, I don't know, a document, you always grab the corner so that you can remain proportional. So this would be like a fun house where you stretch out or shrink down. So in this case, a vertical stretch would be to stretch this out. Okay, make it steeper. Let me show you with my yarn. Okay, so I'm going to stretch this out. Notice the intercept might not change. It's not going to change, but boy, I'm going to get steeper. Or a vertical shrink would be if I were here, oh, I'm going to shrink it down so I'm not as steep. So I'm going to go from a black diamond to a bunny hill. Okay, so let me do it like a parabola. Okay, so a parabola is a U shape. Okay, I'm going to hold it here on the vertex. If I were to do a vertical stretch, I would stretch this up, so it'd be very steep. But a vertical shrink, okay, if I'm bringing my yo-yo down, I'm going to make it look really wide. Okay, so it affects the Y values. It's a multiplier of the Y values. All right, inside we're talking, let me use, so notice this is on the outside, okay? This is on the inside, okay? This is a horizontal stretch or shrink. And the big thing with this is that you have to think opposite, or how about this, reciprocal, okay, of the number. You have to think opposite of the number in front. So when you see a value of, let's say, 2x, it really means a multiplier of a half. So here's what we mean by this, okay? This is really, when I say a horizontal shrink, you have to think, how does that really make a difference? Well, I'm going to tell you what, friends. So here's my not so good looking parabola, okay? If I shrink horizontally, I'm going like this. And if I go like this means this is shrinking in, okay? And that's going to be a shrink. Whereas in a multiplier of, say, y is equal to f of 1/2 x, think opposite, reciprocal, that's 2. That's going to be a stretch. And if you stretch it out horizontally, that's going to make it wider. Okay, so it really just depends where it is on any function, okay? And it works like this, okay? It works with absolute values. It works with all of those things, okay? It really does. And I keep telling my students, let me show you. Oh, I probably didn't need to do this backwards here. Oh boy. Well, this will just be interesting. All right, so this, for example, friends, this goes on and on forever and ever and ever. I guess I could have, there we go. I'll get this. We're doing exponential functions in Algebra 2B, my seniors are. And this is exponential growth. And their initial function looks like this. It like goes on and on forever, and then it shoots up. So it actually goes through 0, 1, just like this, okay? And it gets really, really close to 0, but it never crosses. And you know what? No matter what they have in their formulas, if I can just show you without blowing your minds, this would be an example of something they're doing right now. Let's see, 2 times 2x minus 3 plus 1, okay? And this would be this graph here, okay? Which I know seems really weird, but look at this. This would be to tell them to go 3 to the right. So they'd have to move this 3 to the right. And then they'd have to move it 1 up. And then they need to make it stretch. So you'd actually take this and stretch this up. So see, it doesn't matter what the function is to start, you can still move things. Same way with circles or anything like that, you can move, okay? All right, thanks a lot, friends. Take care.